All right, let's talk about something absolutely critical. We're not just going to be looking at numbers today. We're going to learn how to turn those numbers into real strategy. In any business, you are swimming in data, and the ability to look at a giant spreadsheet and just find its center of gravity, that is a game-changing skill. It's what separates feeling totally overwhelmed from feeling empowered. This is where data-driven decisions begin, and today, we are going to master it.
So, here's our game plan. First, we'll nail down why finding the center is always step one. Then, we'll open up our analytical toolkit and look at the 3 key measures. We'll get into the strategy of picking the right tool, see them in action with some examples, and then, and this is crucial, we'll talk about what happens in the real world when that center starts to move.
All right, let's dive right in with a big foundational problem. How do we find the signal inside all that noise? This first part is all about taking a messy, complex situation and turning it into something clear, something you can actually act on.
I want you to actually picture this. You've got a spreadsheet open. It's filled with thousands of rows. Maybe it's customer feedback scores, daily sales numbers, whatever. It's just a wall of numbers. Staring at that raw data, it can be paralyzing. So what is the very first, most logical thing you do to make sense of all of that?
This is the golden rule, right here. Before you do anything else, before you look for trends, before you hunt for outliers, before you build some complex model, you have to find the one single value that best represents that entire mountain of data. Think of it as your anchor point for the whole analysis. It gives you an instant, high-level grip on what you're even looking at.
And this whole idea, it has a formal name, of course. We call it central tendency. It's not just a number, it's a principle. It's the idea that for pretty much any pile of data, we can find a central point that acts as a summary for everything. And that single value? Well, that's our very first clue to figuring out the story the data is trying to tell us.
Okay, so how do we actually find this central value? Well, we don't just have one way to do it. We have a whole toolkit. And just like with any craft, knowing which tool to pull out for which job, that's what separates the beginners from the pros.
And these are the 3 big ones: the mean, the median, and the mode. Now, you've probably heard these words before, but we're going to look at them from a purely strategic angle. Each one looks at your data through a slightly different lens, and the story it tells you can have major implications for your business.
Let's break down our toolkit. First up, the mean. You know it as the average. Its big plus? It uses every single data point, so it's comprehensive. But that's also its biggest weakness. Imagine you're calculating the average salary at a small company, but you include the CEO's gigantic salary. The mean gets yanked way up, giving you a totally misleading idea of what a typical employee makes. Now look at the median. It's the dead center middle value. It couldn't care less about that huge CEO's salary. It tells you what the person in the exact middle earns, which is often way more useful. The only tiny hassle is you have to sort the data first. And finally, the mode. This one's simple. What's the most popular, most frequent value? If you sell t-shirts, the mode tells you the size you sell most often. Super simple, super powerful. The only catch is, sometimes you have no mode, or you might have a few of them, which can make it a little less useful.
So this brings us to the real strategic heart of it all. It's one thing to know what the tools are, it's another thing entirely to know when to use them. And the right choice, it all comes down to the shape of your data.
And this slide lays it out perfectly. On the left, you've got that classic, beautiful bell curve. We call that a symmetrical distribution. Think about something like the heights of adults. Most people are clustered around the middle, and it's pretty even on both sides. In this case, the mean, median, and mode are all going to be right there in the middle, almost the same. So the mean is a fantastic choice. But look at the right. That's a skewed distribution. And honestly, this is way more common in business data like incomes or sales figures. You get a big clump of data on one side, and then this long tail stretching out. And in this case, the mean gets dragged out towards that tail by the extreme values, giving you a distorted picture. The shape of your data literally tells you which tool to use.
And here is the absolute key takeaway. If you see that skew, if you know you have some outliers that could throw your whole analysis off, the median is your best friend. It becomes your most trusted tool. It just cuts right through that noise and shows you the true center for the vast majority of your data. It's tough, it's reliable, and it resists getting distorted.
Okay, that's enough theory. Let's make this real. We're going to walk through a couple of examples so you can see exactly how these calculations work and what kind of insights pop out.
So for our first scenario, let's keep it simple. Imagine you doing quality control. You've just weighed 10 metal parts coming off the production line, and you need a quick read on the typical weight.
Let's just focus on the median for a second. So we start with our raw data, the 10 numbers. Now the crucial second step, you got to sort it from smallest to largest.
Because we have an even number of data points, 10, there isn't one single value in the middle. No problem. We just grab the two that share the middle spot, in this case the 5th and 6th values. They're both 55. We find the average of those two, which of course is just 55. See? Simple, precise.
So now let's pull back and look at all three measures for this data set. The mean is 54.7. The median is 55. And the mode is also 55. See how close they all are? This is a huge clue. It confirms what we were talking about before. It tells us our data is pretty symmetrical. There aren't any crazy outliers pulling that mean in one direction or the other. In a case like this, honestly, any of the three measures would give you a pretty good sense of the center.
All right, let's level up. Let's tackle something a little more complex but also super common. What happens when you don't have a list of individual numbers, but data that's already been grouped into ranges, like, say, student test scores?
Now, I know this table looks a little intimidating, but it's an incredibly powerful way to handle big data sets. We don't have 35 individual scores here. What we have are counts, or frequencies, for each little bucket of scores. To make it work, we have to approximate a bit. We use the midpoint of each class, like 13 for the 12 to 14 range, as a stand-in for all the scores in that bucket. Then that FX column is just the midpoint times the frequency. The last column, cumulative frequency, just helps us find the middle of the pack. With 35 students total, the middle student is number 18. And if you look at our running total, that 18th student lands squarely in the 18 to 20 marks range.
So what's the big idea here? It's that even with grouped data, you're not just guessing. You can use specific formulas to get a really good approximation of the center. For this particular set of data, the mean works out to be about 19.5. The median, using that class we just found, is around 18.9. Notice that? The mean is a little higher than the median. That's a valuable insight. It tells us there's a slight pull towards the higher scores, a little bit of a positive skew in the data. That is a next-level insight that's totally invisible until you do the math.
Okay, let's get to our final piece of the puzzle. And honestly, this is the concept that really separates a good analyst from a great one. It's this deep understanding that the center you just work so hard to calculate, well, it's not set in stone. In the real world, things change.
Think about it. You can calibrate a machine perfectly today, but over a few weeks, a few months, with normal wear and tear, temperature changes, whatever, its output is naturally going to drift away from that perfect starting point. This idea of process drift is a cornerstone of methodologies like Six Sigma. It's about accepting that stability isn't a one-and-done deal. It's something you have to constantly work for.
Now, in a perfect, theoretical, lab-controlled world, a Six Sigma process, one that's perfectly centered and never moves, would produce a number of defects so small it's hard to even wrap your head around. We are talking about 2 defects for every billion opportunities. That is almost absolute perfection.
But what happens in the real world? The accepted standard for a world-class Six Sigma process allows for 3.4 defects per million. So what explains that gigantic leap from billion with a B to million with an M? It's the realistic, data-backed acceptance of an almost inevitable 1.5 sigma drift over the long haul. This isn't seen as a failure. It's a smart, realistic view of how complex systems actually behave over time.
And this quote just hits the nail on the head. Finding the center is step one, but the real strategic work is monitoring that center over time, understanding how and why it's shifting, and making smart adjustments to keep your process on track. It's a dynamic, never-ending challenge. So, this is where we'll leave it. You now get that every data set has a center of gravity. You've got the toolkit, mean, median, and mode to go find it. You've got the strategy to choose the right tool for the job based on the shape of your data. And most importantly, you now appreciate that this center is not a fixed point. Your data is always talking, always telling a story. The question is no longer what it's saying. The question is, what strategic story are you going to choose to tell with it?